You are standing in your kitchen right now, staring at the open refrigerator, and you have absolutely no idea why you are here. You walked in with purpose. You had a mission. And now, nothing. Your brain has just completely blanked on you. The milk stares back at you judgmentally. The leftover pizza offers no answers. You close the door defeated, and the memory hits you like a slap. Water. You wanted water. The thing that is literally right next to the fridge. Your brain just forgot mid-mission and sent you to the wrong location entirely. Congratulations, you just experienced what scientists call a retrieval failure, and you are in good company because AI does this too. Except when AI forgets where it put the metaphorical water, people can die, markets can crash, and your recommended videos can get really, really weird. Tonight we are diving deep into what happens when AI starts to forget the memory of machines. And before you think this is just another tech video about computers doing computer things, let me stop you right there. This is about the uncanny, uncomfortable, and sometimes hilarious ways that the smartest technology we have ever built is starting to develop the same memory problems as your forgetful aunt, who keeps asking if you are still in school, even though you graduated 5 years ago. So here is what I need from you. Hit that like button if you have ever walked into a room and completely forgotten why. Drop a comment telling me the weirdest thing you have ever forgotten and where you are watching this from. And now turn down the lights. Get comfortable. Maybe put your phone on Do Not Disturb, because we are about to go deep, and trust me, you are going to want to pay attention to this one. Let me set the scene. It is 2024, and we are living in what tech companies breathlessly call the age of AI. You have got chatbots that can write poetry, image generators that can create photorealistic pictures of things that never existed, and recommendation algorithms that know you want to watch true crime documentaries at 2 a.m. before you even know it yourself. These systems are supposed to be perfect, flawless. They are machines, right? They do not get tired, they do not get distracted, they do not suddenly forget what they were doing because they saw a cute dog video, except, and this is the part that nobody really talks about, they absolutely do forget. Not in the way you forget your anniversary, although given how many AI assistants are managing people's calendars now, that is probably happening too. No, AI forgets in ways that are simultaneously more predictable and more bizarre than human forgetting. They forget systematically, deliberately, sometimes catastrophically, and understanding how and why they forget tells us something profound about our own memories, our own minds, and what it actually means to know something. You think memory is simple. You experience something, your brain files it away, and you retrieve it later when you need it. Like saving a document on your computer. Click save, close the file, open it later, boom, there it is, exactly as you left it. But that is not how memory works, not for you, and definitely not for AI. Your brain is not a hard drive, it is more like a constantly remodeling house where the walls keep moving, the furniture rearranges itself when you are not looking, and sometimes entire rooms just vanish because your brain decided you do not need them anymore. Every time you remember something, you are not pulling up a saved file, you are rebuilding it from fragments, filling in gaps with educated guesses, and sometimes just making stuff up entirely without realizing it. AI does something weirdly similar. When a neural network, the kind of AI that powers most of the smart technology you use, learns something, it does not store that information as a discrete file. It adjusts millions or billions of tiny parameters, numerical weights that collectively create patterns. Those patterns are the memory. And here is the thing. Those patterns can fade, they can interfere with each other, they can get overwritten, the AI can forget. Let me give you a concrete example. that will make this click. Imagine you are teaching an AI to recognize animals. You show it thousands of pictures of cats, tabby cats, Persian cats, those angry-looking hairless cats that seem perpetually disappointed with existence. The AI learns. It gets really good at cats. You show it a cat, any cat, and it nails it every time. Gold star for the robot. Now you decide to teach it about dogs. Thousands of dog pictures. Golden retrievers with their perpetually happy faces, tiny chihuahuas that are mostly anxiety and trembling, those huge dogs that look like they could be in a fantasy novel. The AI learns dogs. It is crushing the dog identification game. You are proud, but then, and this is where it gets weird, you show it a cat again. Just a regular orange tabby. Nothing fancy. And the AI hesitates. It is not as confident anymore. Some of the fine details, the subtle features that distinguish cat breeds, they have gotten fuzzy. The cat knowledge has degraded. It has not completely vanished, but it is definitely not as sharp as it was before you taught the dog stuff. What just happened? The AI forgot. Not completely, but partially. This is called catastrophic forgetting. And yes, that is the actual scientific term. Researchers looked at this phenomenon and collectively decided that catastrophic was the appropriate level of concern, because when an AI learns something new, it often has to partially forget something old. The new knowledge overwrites the old knowledge. The parameters that encoded cat recognition get adjusted to encode dog recognition, and in the process the cat patterns get disrupted. It is like trying to use the same whiteboard for two different classes. You can erase the calculus equations to make room for the chemistry formulas, but then you have lost the calculus. You cannot have both, unless you get a bigger whiteboard or figure out a very clever way to organize the space. Now you might be thinking, okay, but computers have basically unlimited memory these days. My phone can store thousands of photos and videos. Why not just give the AI more space? And that is a completely reasonable question that misses the fundamental weirdness of how AI memory works. Because the problem is not storage capacity. Your phone stores those photos as passive data. They just sit there taking up space, waiting for you to look at them. They do not do anything. But AI memory is active. It is the structure of the network itself. It is the connections between artificial neurons, the strength of those connections, the way information flows through the system. When an AI knows something, that knowledge is distributed across the entire network. There is no separate folder for cat knowledge and dog knowledge. It is all interconnected, all sharing the same underlying architecture, all competing for the same representational resources. Think about it like this. Your brain has about 86 billion neurons and trillions of connections between them. That is a lot of hardware. But you do not remember everything you have ever experienced. You do not remember every breakfast, every conversation, every step you have ever taken. Because memory is not just about having the storage space. It is about having useful, organized, retrievable patterns. And maintaining those patterns while adding new ones is really, really hard. AI faces the same challenge. A big neural network might have billions of parameters, which sounds like a lot, but it is trying to capture incredibly complex patterns from massive amounts of data. And all those parameters have to work together coherently. You cannot just keep adding parameters forever. Well, you can, but the computational cost becomes astronomical, and at some point the network becomes so large that it is impossible to train effectively. So AI has to make choices. What to remember and what to forget. What to prioritize and what to let fade. And unlike your brain, which has had millions of years of evolution to develop clever memory management strategies, AI is still figuring this stuff out. We are basically teaching these systems on the fly, discovering their limitations in real time, often in hilariously inconvenient ways. So why does forgetting exist at all? I mean, if memory is so valuable, if the whole point of intelligence is to learn from experience, why would evolution design a brain that leaks information like a sieve? It seems like a terrible design choice. Like building a bucket with holes in it and calling it a feature. But here is the thing that neuroscientists figured out, and that is now blowing AI researchers' minds. Forgetting is not a bug, it is a feature. A crucial, possibly essential feature. And understanding why humans forget can teach us a lot about what AI should be doing with its memory. You are not supposed to remember everything. If you did, you would be completely non-functional. There is a famous case in neuroscience literature about a man named Solomon Cheryshev who had a condition called hyperthymesia, essentially a perfect memory. He could remember everything, every detail of every day, every face, every conversation, every random street he walked down, and it tortured him. He could not think abstractly because his mind was constantly flooded with specific memories. He could not see a tree without remembering every individual tree he had ever seen. He could not have a conversation without being distracted by memories of every other conversation. His perfect memory made him unable to function in normal life, because here is the secret. Intelligence is not about remembering everything. It is about remembering the right things and forgetting the rest. Your brain is constantly filtering, constantly deciding what is worth keeping and what should be discarded. That boring meeting from last Tuesday, gone. The exact pattern of clouds you saw on your commute 3 weeks ago, deleted. The name of that person you met once at a party. Your brain took one look at that information and said, yeah, we are not keeping this. And it was right. Because if you remembered all that stuff, you would not have room for the things that actually matter. The important conversations, the skills you use regularly, the faces of people you love, the knowledge that keeps you alive and functioning. Forgetting is a form of optimization. It is your brain managing limited resources, focusing computational power on what is relevant and useful. And this is exactly what AI needs to learn to do. Right now, most AI systems are trained on massive datasets, and they try to extract every possible pattern from that data. They are like students trying to memorize an entire textbook word for word, and just like those students, they often end up overfitting. They memorize the specific examples instead of learning the underlying principles. Let me give you an example. Say you are training an AI to recognize spam email. You feed it thousands of examples. Emails about Nigerian princes, offers for suspicious pharmaceuticals, notifications that you have won a lottery you never entered. The AI learns patterns. Certain words show up a lot in spam, certain grammatical structures, certain formatting choices. But if the AI just memorizes the specific training examples, it is useless, because spammers are not going to send the exact same emails over and over. They change things up, they evolve, they get creative. So the AI needs to forget the specific details and remember the general patterns. It needs to abstract, it needs to generalize, and that requires letting go of information. There is a technique in machine learning called dropout that literally forces the AI to forget during training. You randomly turn off some of the neurons in the network, different ones each time. This prevents the network from memorizing specific pathways and forces it to learn robust, flexible representations. And the result, the AI actually performs better. It generalizes better to new data. It is less brittle, all because you made it forget. Similarly, there are regularization techniques that penalize the AI for being too confident, for fitting the training data too perfectly. You essentially tell the AI, do not try so hard, stay a little uncertain, stay a little forgetful, and paradoxically that makes it more accurate in the real world, because the real world is messy and unpredictable, and an AI that has memorized the training data perfectly is going to fail spectacularly when it encounters something even slightly different. Now let us talk about what happens when AI forgets in real time while it is actually running and making decisions. Because it is not just about what happens during training. AI systems that operate in the real world, that learn continuously from new data, face an even trickier memory challenge. Imagine you are a recommendation algorithm for a streaming service. Your job is to figure out what people want to watch and suggest it to them. You learn from their behavior. Someone watches 3 romantic comedies in a row. Okay, they probably want more romantic comedies. You adjust your recommendations, but people change. Tastes evolve. Someone who binged romantic comedies last month might be really into crime documentaries this month. Maybe they went through a breakup. Maybe they are just bored. The point is, you need to adapt. You need to update your model of what this person likes. But if you update too aggressively based on recent behavior, you forget their long-term preferences. You overreact to short-term trends. And then when they go back to wanting romantic comedies, you are caught off guard because you have forgotten they ever liked them. This is the explore-exploit dilemma, and it is all about memory management. Do you rely on what you have learned in the past, your accumulated memory, or do you prioritize new information and let the old stuff fade? There is no perfect answer. You have to balance. You have to decide how much weight to give to old memories versus new experiences. Get it wrong, and you end up with an AI that either cannot adapt to change or cannot maintain any consistent understanding of the world. Self-driving cars face a similar problem. A self-driving car is constantly learning about its environment. It is tracking other vehicles, predicting their movements, identifying obstacles, planning routes, and all that information is time-sensitive. Where another car was 5 seconds ago is less important than where it is right now. The AI needs to forget old positions and focus on current ones. But it also needs to remember patterns. It needs to remember that this particular intersection is tricky, that pedestrians often cross here, that the traffic light timing is weird. So it is constantly balancing short-term, rapidly updating memory with long-term stable memory. Mess that up, and you get a car that either reacts too slowly because it is stuck on outdated information, or overreacts to every little thing because it has no historical context. Human brains do this effortlessly. You have different memory systems for different purposes. Working memory for stuff you need right now. Short-term memory for recent events. Long-term memory for stable knowledge. And these systems interact, sharing information, updating each other, all without you having to consciously manage them. AI is trying to build something similar, but it is really hard. Most AI systems have one unified memory structure, and that structure has to somehow handle both ephemeral, immediate information and long-term stable knowledge. It is like trying to use the same notebook for your grocery list and your life philosophy. Technically possible, but not ideal. Some researchers are now building AI with explicit memory hierarchies, inspired by the brain. You have a fast-changing memory for immediate context and a slow-changing memory for stable knowledge. The two interact, but they update at different rates, and early results are promising. These systems are better at adapting to new situations without forgetting old knowledge. They are better at balancing stability and flexibility. But we are still in the early stages. We are still figuring out the right architectures, the right update rules, the right ways to decide what should be remembered long-term and what should be quickly forgotten. And every time we make progress, we discover new problems. Because memory is not just one thing, it is a whole ecosystem of interacting processes, and replicating that in machines is one of the hardest problems in AI. Let us get personal for a moment. Let us talk about what your memory actually is, because understanding human forgetting is the key to understanding why AI memory is so weird. Right now, I want you to think about your earliest memory. Go ahead, really try to picture it. Maybe it is a birthday party. Maybe it is a family vacation. Maybe it is something mundane, like sitting in your childhood kitchen. You have got the image in your head. You can see it, maybe even feel it a little bit. Colors, sounds, emotions. Here is the uncomfortable truth. That memory is probably not real, or at least it is not accurate. You are not remembering the actual event. You are remembering the last time you remembered it. And each time you remember, you change it. You add details that were not there. You remove details that were. You blend in information from other memories, from photos you have seen, from stories people have told you. Your memory is not a video recording. It is a story you keep rewriting. Neuroscientists have demonstrated this over and over. They can implant false memories in people pretty easily. They just have to suggest something happened, provide some context, and your brain will happily construct a detailed memory of an event that never occurred. You will swear it is real. You will argue about it, but it is fiction. Your brain made it up, and this happens not because your brain is broken, but because this is how memory is supposed to work. Memory is not about preserving the past with perfect fidelity. It is about extracting useful information from experience and using it to navigate the future. The specific details do not matter. What matters is the gist, the pattern, the lesson. You do not need to remember exactly what the predator looked like. You need to remember that things with sharp teeth are dangerous. You do not need to remember every word of a conversation. You need to remember whether the person was trustworthy. Your brain compresses, abstracts, generalizes, and in the process it forgets almost everything. AI does something eerily similar. When a neural network learns from data, it does not store that data. It extracts patterns. It compresses the information into a much smaller set of parameters. A language model trained on billions of words does not remember those specific words. It learns statistical patterns about how language works. And when you ask it to generate text, it is not retrieving anything. It is reconstructing, creating something new that follows the patterns it learned. Just like you reconstructing a memory, and just like your memories, AI-generated content is not accurate reproduction. It is plausible fiction based on learned patterns. This is why AI hallucinates. That is the term researchers use when an AI confidently states something completely false. It is not lying, exactly. It is not trying to deceive you. It is just doing what it is designed to do, generating plausible sounding content based on patterns. But it has no way to verify whether that content is actually true. It has no real memory of the source material. It just has patterns. And sometimes those patterns produce something that sounds right but is completely wrong. You do this too. All the time, you confidently remember events that did not happen. You misattribute quotes. You create false connections between ideas. Your memory hallucinates constantly. You just do not usually call it that. And here is the really interesting part. The mechanisms that cause forgetting in AI, things like catastrophic forgetting and interference, they have direct parallels in human memory. When you learn something new, it can interfere with old memories. This is well documented in psychology. Learn a new language, and your native language gets a little fuzzy. Learn a new phone number, and you forget the old one. The new overwrites the old, just like in AI. There is even a phenomenon called retrieval-induced forgetting. When you practice remembering some things, you actually get worse at remembering related things. Your brain is allocating resources, strengthening some memories at the expense of others. It is making choices about what to keep and what to let fade, exactly like AI. So, if human memory is this unreliable, constantly changing, fiction-generating process, why does it work so well? Why are you able to function in the world despite having a memory system that is basically lying to you all the time? The answer is context. Your memory is not a standalone database. It is embedded in a rich network of knowledge, skills, and understanding. When you remember something, you are not just retrieving an isolated fact. You are activating a whole web of related information. You are using context to fill in gaps, to check plausibility, to reconstruct details. And most of the time, this works. You get the gist right, even if the details are wrong. And the gist is usually enough. AI struggles with this because most AI systems lack rich contextual understanding. They have patterns, but they do not really understand what those patterns mean. They do not have a model of the world that they can use to sanity check their outputs. So when they reconstruct information from their compressed representations, from their patterns, they have no way to know if the reconstruction makes sense. They just generate whatever the patterns suggest. This is starting to change. Newer AI systems are being built with more sophisticated world models, more contextual awareness. They are learning not just patterns in data, but relationships between concepts, causal structures, temporal dynamics. They are building something closer to understanding, and as they do, their memory becomes more robust. They are better at knowing what they know and what they do not know. They are better at using context to guide recall. They are better at distinguishing between confident knowledge and uncertain extrapolation. But we are still far from human-level memory integration. Your brain seamlessly blends episodic memory, specific events you have experienced, with semantic memory, general knowledge about the world, with procedural memory, skills and habits you have learned. All these memory systems interact, inform each other, create a coherent sense of self and world. AI memory is still mostly siloed, different systems for different purposes, not really talking to each other, not really integrated. A language model might have vast semantic knowledge, but no episodic memory. It cannot remember your previous conversations unless you feed them back into it. A game-playing AI might have excellent procedural memory, perfect execution of learned strategies, but no semantic understanding of what it is doing or why. We are building specialist memory systems, not generalist ones, and that limits how well they can handle forgetting. Because good forgetting requires understanding what is important, and importance is contextual. It depends on goals, on relationships, on values, things a specialized AI does not have. You know what is important to you. Your brain knows what to prioritize in memory. The first time you met your best friend, important, keep that. The layout of a hotel room you stayed in once 5 years ago, not important, forget it. Your brain makes these decisions automatically, based on a lifetime of learning about what matters to human survival and thriving. AI does not have that. It has optimization metrics defined by engineers. It remembers what it is rewarded for remembering, and forgets what it is not penalized for forgetting. The criteria are external, arbitrary from the AI's perspective. It has no intrinsic sense of importance, and that leads to some weird outcomes. An AI might remember useless trivia, while forgetting critical information, simply because the training process happened to emphasize one over the other. It might over-focus on recent data, and forget long-term trends. It might do the opposite. There is no built-in wisdom about what matters. That has to be engineered in, and it is really hard to get right. Alright, time to talk about when AI forgetting goes wrong. Because it is one thing to understand the mechanisms, the technical reasons why AI forgets. It is another thing entirely to grapple with the consequences when those forgetting processes happen at the worst possible moment. Imagine this. You are sick, really sick. You go to the hospital and they run a bunch of tests. The doctors are using an AI diagnostic system to help interpret your medical images, your blood work, your symptoms. This AI has been trained on millions of patient records. It is supposed to be really good at catching things human doctors might miss. And it flags something, a pattern in your scans that could indicate a serious condition. The doctors investigate further. Turns out the AI was right. Early detection saves your life. Great story, right? AI for the win. Now imagine the same scenario, but this time the AI has just been updated. The hospital upgraded to a newer version that is supposed to be better at detecting a different set of conditions. More accurate overall, according to the metrics, but in the process of learning to detect those new conditions, the AI has partially forgotten how to detect the thing you have, the pattern it would have flagged before. It misses it this time. The doctors, trusting the AI, do not investigate further. The condition goes undetected until it is too late. This is not science fiction. This is a real risk with continually learning AI systems in high-stakes domains. When an AI updates, when it learns new things, it can forget old things. And if those old things were important, people can get hurt. The technical term is negative backward transfer, but let us just call it what it is. Dangerous forgetting. And it is not just healthcare. Financial AI systems that forget how to detect certain types of fraud. Security systems that forget how to recognize certain threats. Autonomous vehicles that forget how to handle rare but critical edge cases. Any domain where AI is making important decisions, forgetting is a serious problem. So how do we prevent this? How do we build AI that can learn and adapt without forgetting critical knowledge? One approach is rigorous testing. Before you deploy an updated AI, you test it extensively on all the old tasks, all the old scenarios, to make sure it has not regressed. You have benchmark datasets, test suites, validation protocols. You check that the new version is at least as good as the old version on everything important. This works, but it is expensive and time-consuming, and it only catches forgetting that you know to test for. If the AI forgets how to handle some rare scenario that is not in your test suite, you will not catch it until it fails in the real world. Another approach is conservative updating. You make the AI change slowly, incrementally, always preserving core functionality. You use techniques like elastic weight consolidation, which we talked about earlier, to protect important parameters from being changed too much. You prioritize stability over rapid learning. This reduces the risk of catastrophic forgetting, but it also slows down improvement. You are trading off adaptability for safety, which might be the right call in high-stakes domains, but it is still a trade-off. Then there is the idea of ensemble systems. Instead of relying on one AI that keeps updating, you maintain multiple versions. The old model, the new model, maybe some intermediate versions, and when you need to make a decision, you consult all of them. If they agree, great. If they disagree, that is a red flag. Maybe you defer to human judgment. Maybe you investigate further. The disagreement itself is information. This is more robust, but it is also more complex and computationally expensive. You are running multiple models in parallel, maintaining multiple versions, dealing with conflicts between them. Not always practical. Here is where things get philosophical. What if the problem is not that AI forgets, but that we expect it not to? What if we are asking the impossible? Humans forget constantly, inevitably. And we have built entire social and institutional structures to deal with that. We write things down. We create redundancy. We have multiple people check important decisions. We build in error correction and appeals processes. We accept that memory is fallible, and we plan accordingly. But with AI, we seem to expect perfection. We want systems that never forget, never make mistakes, never degrade, and when they do, we treat it as a failure. But maybe that is the wrong frame. Maybe we should be designing systems that assume forgetting will happen and build in safeguards accordingly. Like how we do not trust one person's memory for critical information. We corroborate, we document, we create institutional memory that is more reliable than individual memory. We could do the same with AI. Do not rely on one model. Use multiple systems with different training histories, different strengths, different failure modes. When they agree, you can be confident. When they disagree, you know you need to be careful. Create external memory systems that AI can reference, not just training data, but curated, verified knowledge bases that the AI can consult when making important decisions. Kind of like how you might double-check your memory by looking something up. The AI's internal learned patterns are the first pass, but critical decisions get verified against external sources. Build in mechanisms for detecting when the AI is uncertain or operating outside its training distribution. When it is in territory where forgetting might have occurred, where its learned patterns might not apply, and in those cases defer to humans or more conservative decision rules. This is starting to happen in some domains. Medical AI systems that flag when they are uncertain and recommend that a human specialist review the case. Financial systems that have circuit breakers when they detect unusual patterns. Autonomous vehicles that hand control back to the human driver in situations they have not been trained for. But we need more of this. We need to build AI with the assumption that memory is imperfect, that forgetting will happen, and that safety requires multiple layers of redundancy and verification. Not because the AI is bad, but because memory is hard for humans and machines alike. There is also a deeper question about whether we even want AI that never forgets, because perfect memory might not be desirable. Remember the case of Solomon Shirashevsky, the man who could not forget anything. It made him unable to function. Too much memory can be as bad as too little. AI might need to forget in order to generalize, to adapt, to stay relevant. The challenge is controlling what gets forgotten and what gets preserved, making sure the forgetting is useful, not harmful. And that requires understanding not just the technical mechanisms of memory, but the context in which the AI is operating. What is it trying to do? What knowledge is critical for that task? What can safely be discarded? These are not purely technical questions. They are questions about values, priorities, goals, and they require human judgment. We cannot just optimize for some abstract metric and hope that produces the right forgetting behavior. We need to actively design memory management strategies that align with our needs and values. Which brings us to an uncomfortable realization. As AI systems become more complex, more capable, more integrated into critical infrastructure, we are not just building tools. We are building entities with something like cognitive processes, perception, learning, memory, forgetting. And we are discovering that all the messy, complicated, frustrating aspects of human cognition, all the things we thought we could engineer away, they are not bugs. They are intrinsic to how intelligence works. You cannot have learning without forgetting. You cannot have generalization without abstraction. You cannot have adaptation without plasticity. And plasticity means things change, things are forgotten, things are lost. The question is not whether AI will forget, it will. The question is whether we can manage that forgetting wisely. Let us zoom out and talk about something that sounds like science fiction, but is actually happening right now. AI systems that can modify their own memory, that can decide what to remember and what to forget, that have something approaching metacognition, thinking about thinking, or in this case, remembering about remembering. There is a whole branch of AI research focused on building systems with explicit memory management, not just passively absorbing information and hoping the right patterns emerge, but actively curating knowledge, deciding what to store, what to discard, what to revisit. It is called memory augmented neural networks, and it is wild. Here is how it works. Traditional neural networks, the kind we have been talking about, store everything in their parameters, the weights and connections of the network, encode all the knowledge. But memory augmented systems have an external memory component. Think of it like RAM in a computer, separate from the processor. The neural network can read from this memory and write to it. It can store specific information, retrieve it later, even overwrite it when it is no longer needed. And here is the key part. The network learns how to use this memory. It learns what to store, when to retrieve it, when to forget it. It develops its own memory management strategies. Some of these systems use attention mechanisms to decide what to focus on in memory. Just like you do not pay equal attention to all your memories, you focus on what is relevant to the current situation. The AI learns to selectively attend to the parts of its memory that are useful for the task at hand. Others use something called neural Turing machines, which can perform read and write operations on memory in a very structured, algorithmic way. The AI learns programs, sequences of memory operations that solve problems. It is like learning not just facts, but also how to organize and manipulate those facts. And the results are impressive. Memory augmented networks can handle tasks that traditional networks struggle with, tasks that require remembering specific details over long periods, tasks that require complex reasoning with multiple pieces of information, tasks that look a lot like what we would call intelligent memory use, but they also exhibit forgetting, because the external memory is finite. It cannot grow indefinitely. So the AI has to make choices, what to keep and what to overwrite. And watching these systems learn to manage memory is fascinating because they discover strategies that look eerily human. They tend to keep frequently accessed information and discard rarely used information. They prioritize recent information over old information unless the old information has proven repeatedly useful. They create shortcuts, compressed representations of common patterns to save memory space. They are reinventing the principles of human memory management through pure trial and error. Nobody programmed these strategies in. The AI figured them out because they work, and that tells us something profound. Good memory management is not arbitrary. It is not just a quirk of how human brains happen to be built. It is a fundamental requirement for efficient learning and reasoning with limited resources. Any intelligent system, biological or artificial, has to solve the same problem. Too much memory, and you are overwhelmed. Too little, and you cannot function. The right amount, organized the right way, with the right forgetting mechanisms, that is the sweet spot. And AI is discovering this on its own. Now this raises some fascinating questions. If AI can manage its own memory, can it also manipulate it? Can it deliberately forget things it does not want to remember? Can it rewrite its own history? With humans we know memory manipulation is possible. Therapy techniques like EMDR can help reduce the emotional intensity of traumatic memories. Meditation practices can change how we relate to our past, and unfortunately, propaganda and gaslighting can implant false memories or make people doubt their real ones. Memory is malleable, And if AI memory is similarly flexible, similarly subject to modification, what does that mean? Could an AI be trained to forget certain information for privacy or security reasons? Could it be made to forget biases in its training data? Could it selectively erase knowledge that might be used harmfully? Or conversely, could a malicious actor manipulate an AI's memory, implanting false information, erasing critical knowledge, creating blind spots? These are not hypothetical concerns. There is active research on machine unlearning, techniques for making AI forget specific information. This is important for privacy. If an AI was trained on your data and you want that data removed, how do you make the AI forget it? You cannot just delete the training data, because the information has already been incorporated into the model's parameters. The AI has learned from it. So you need techniques to reverse that learning, to erase the influence of specific data points. And it turns out this is really hard, because knowledge in a neural network is distributed and interconnected. Removing one piece of information can have unpredictable effects on other knowledge. You might successfully make the AI forget your data, but accidentally degrade its overall performance. Or you might think you have erased something, but it is still there, encoded implicitly in subtle patterns. The plot thickens when you consider that some researchers are working on AI systems that can explain their own reasoning. Interpretable AI, explainable AI. These are systems that do not just make decisions, but can tell you why they made those decisions. And a big part of that why is memory. What did the AI remember that led to this conclusion? What patterns did it recognize? What past experiences is it drawing on? But if the AI can forget, if its memory changes over time, then its reasoning changes too. An AI might make a decision today that it would not make tomorrow, not because the inputs changed, but because its memory has evolved. It has learned new things, forgotten old things, shifted its priorities. This is normal for humans. You make decisions based on your current understanding, your current memory, and those change over time. You look back at past decisions and think, what was I thinking? Well, you were thinking with a different set of memories than you have now. AI will do the same. And that creates challenges for accountability. If an AI makes a harmful decision, and we want to understand why, we need to know what it knew at the time. But if its memory has changed since then, if it has learned and forgotten in the interim, we cannot just ask the current version of the AI. Its memory is different now. We need something like a memory snapshot from the time of the decision. This is starting to be implemented in some high-stakes AI systems. Version control for AI models. Logging not just what decisions were made, but what the model's state was at the time. So you can reconstruct the reasoning after the fact. It is like keeping a detailed journal of your own thoughts and memories, so you can look back and understand your past self. Cumbersome, but necessary for accountability. There is also the question of whether AI should be allowed to forget certain things. Should there be knowledge that is protected, that cannot be erased or modified? Think about AI systems used in legal or historical contexts. If an AI has learned important information about past events, should it be able to forget that? Should we be able to make it forget? Or is there value in preserving that knowledge, even if it is uncomfortable or inconvenient? Humans struggle with this too. We have ongoing debates about historical memory. What should be preserved? What should be taught? How should we remember difficult histories? Monuments get built and torn down. Curricula get revised. Archives get curated or neglected. Memory is political. And as AI becomes a repository of collective knowledge, those same political questions will apply to AI memory. Who decides what AI remembers and forgets? Who has the power to modify AI knowledge? And how do we ensure that power is not abused? These are not just technical questions. They are ethical and political questions that we are going to have to grapple with. Here is another twist. Some researchers are exploring whether AI can develop false memories, just like humans do. Not errors or hallucinations, which we have already talked about, but memories of things that were explicitly suggested, but never actually in the training data. And the answer is yes. You can implant false memories in AI. You can feed an AI some initial training data, then give it suggestions, hints, prompts that imply certain information exists, and the AI will often confabulate, generate plausible details that fill in the gaps. It will create memories of patterns that were never there, just like humans do in eyewitness testimony, in therapy, in everyday conversation. Someone suggests something happened a certain way, and your brain happily constructs a memory to match, even if it is wrong. AI does the same. And this has serious implications. It means AI memory is not just fallible in the sense of forgetting, it is also vulnerable to manipulation, to suggestion, to the creation of false knowledge, and distinguishing between real learned patterns and implanted false patterns is difficult. For AI and for humans, we are building systems that mirror our cognitive processes, including our cognitive vulnerabilities, and that is both powerful and dangerous, because it means AI can be deceived, can be manipulated, can be gaslit just like humans can. And if we are relying on AI for critical decisions, we need to be aware of these vulnerabilities and build defenses against them. Which brings us back to a central theme. AI memory is not like computer storage, it is like human memory. Fallible, flexible, context-dependent, vulnerable, and understanding that similarity, really grasping it, is crucial for building AI we can trust, and for understanding our own minds better. So where does all this leave us? We have talked about catastrophic forgetting, about interference, about memory management strategies, about the parallels between AI and human memory. We have explored how forgetting can be useful, how it can be dangerous, how it is inevitable. Now let us bring it home. What does AI forgetting teach us about ourselves? Because that is the real revelation here. In trying to build machines that remember, we are discovering just how strange and wonderful our own memory is. You take your memory for granted. You assume it is just there, a reliable record of your past, a stable foundation for your identity. But it is not. It is a constantly shifting, actively constructed, deeply unreliable process, and yet it works. You navigate the world, learn from experience, maintain relationships, build knowledge, all with this janky, error-prone memory system. How? Because you do not need perfect memory. You need useful memory. You need to remember enough to make good decisions, to learn from mistakes, to recognize patterns. The details do not matter. The gist does, and your brain has evolved incredibly sophisticated mechanisms to extract the gist and discard the details. AI is teaching us to appreciate this, because when we try to build memory systems from scratch, we realize how hard it is, how many trade-offs are involved, how much implicit knowledge goes into deciding what to remember and what to forget. Your brain does this effortlessly, automatically, without you ever thinking about it. And that is astounding. There is also something humbling about watching AI struggle with the same memory problems we have. We built these systems to be better than us, faster, more accurate, more reliable, and in many ways they are. An AI can process more information in a second than you can in a lifetime, but it still forgets. It still makes errors. It still has to balance competing demands on limited resources. It is not a transcendence of human limitations. It is a reflection of them, because the limitations are not bugs. They are features of what it means to be intelligent in a complex, changing world. Perfect memory is not just impossible, it is undesirable. It would make you rigid, unable to adapt, overwhelmed by irrelevant details. Forgetting is what allows you to generalize, to abstract, to focus on what matters. AI has to learn the same lesson, and watching that process unfold is giving us new insights into our own cognition. Neuroscientists are now using AI models to test theories about human memory. If we build an AI with a certain memory architecture, does it exhibit the same forgetting patterns as humans? If so, that suggests the architecture might be similar to what is happening in the brain. If not, we need to revise our theories. AI is becoming a tool for understanding ourselves, a mirror that reflects our cognitive processes back at us in a form we can study and manipulate. And the reflection is fascinating. Here is something that blew my mind when I first learned about it. There is a theory in neuroscience that sleep is partially about forgetting, not just consolidating important memories, but actively pruning away weak connections, clearing out the clutter. Your brain uses sleep to reset, to make room for new learning, and there is evidence that AI benefits from something similar. Researchers have experimented with giving AI rest periods, times when it is not learning new information, but instead reviewing and consolidating what it has learned, and it helps. The AI retains information better, generalizes better, exhibits less catastrophic forgetting. It is like the machine version of a good night's sleep, which suggests that forgetting during rest is not a passive decay. It is an active process of optimization. Your brain is not just failing to maintain memories, it is deliberately choosing what to keep and what to discard. And AI is discovering that the same strategy works for machines. We are learning that intelligence, whether biological or artificial, requires forgetting, not as a failure, but as a core function, and that changes how we should think about memory in both contexts. Let me leave you with this. You are going to forget most of what you watched in this video. Probably within a few days, the specific details will start to fade. The examples, the exact phrasing, the order of topics. In a month you will remember the gist. AI forgets. It is like human memory. There are some interesting technical details. In a year you might remember that you watched something about AI memory once, or you might forget entirely. And that is okay. That is how memory works. But here is what I hope sticks. The next time you forget something, the next time you walk into a room and have no idea why you are there, the next time you cannot remember a name, or a fact, or an experience you know you should recall, do not beat yourself up. You are not broken. Your memory is not failing. It is doing exactly what it is supposed to do, managing limited resources, prioritizing what matters, making space for new learning. You are optimized for a complex, changing world, and forgetting is part of that optimization. The machines we are building, the most advanced AI systems in the world, they have to learn the same lesson. They have to forget to function. And in teaching them how to forget wisely, we are learning to appreciate the wisdom of our own forgetting. So here is my challenge to you. Pay attention to what you forget this week. Not with frustration, but with curiosity. What is your brain choosing to discard? What is it choosing to keep? What does that tell you about your priorities, your values, your current state of mind? And drop a comment telling me what you discovered. What did you forget? What did you remember? What surprised you? Also, let me know what you think about AI memory. Are you worried about AI systems forgetting critical information? Are you excited about AI that can manage its own memory? Do you think we should be building AI that mirrors human cognition, flaws and all, or should we be trying for something fundamentally different? I want to hear your thoughts. And if you enjoyed this deep dive into the weird intersection of neuroscience and AI, hit that like button, subscribe for more videos like this, and check out the playlist where I explore other fascinating topics at the edge of technology and humanity. Before you go, here is one last thing to think about. We have spent this whole video talking about forgetting as loss, information disappearing, knowledge fading, memories erasing, but maybe that is the wrong frame. Maybe forgetting is not about loss. Maybe it is about transformation. When you forget the details and remember the pattern, you have not lost information. You have transformed it into something more useful, more general, more applicable. When AI forgets specific training examples and learns underlying principles, it is not losing knowledge. It is evolving it. When your brain prunes weak memories and strengthens important ones, it is not failing. It is sculpting, creating something refined from something raw. Forgetting is not the opposite of remembering. It is part of the same process. Learning, remembering, and forgetting are all aspects of how intelligent systems, biological and artificial, adapt to the world. You cannot have one without the others. And maybe that is the real lesson here. Intelligence is not about accumulating information. It is about transformation, taking an experience, extracting meaning, discarding the irrelevant, building understanding, and forgetting is essential to that process. So the next time an AI forgets something, the next time you forget something, maybe we should not see it as a failure. Maybe we should see it as evidence that learning is happening, that adaptation is occurring, that intelligence, real intelligence, is at work. Thank you for watching. Thank you for thinking about this with me, and I will see you in the next video. Now go forget something important. Your brain will thank you.